Hi everyone, my name is Mikiko, and today I'll be presenting a talk on how to make multimodal generative AI work for you. So recently, I just come from CVPR 2024's CVPR in Seattle with my team at Ladlebox, and something that we had observed was that multimodal was a really big theme, and not just because we had autonomous driving vehicle companies there or robotics companies there, but also because there's just a lot of like really interesting, valuable use cases for multimodal generative AI. So I thought it'd be incredibly useful to actually discuss, what do you as a team, either maybe you're an AI lab that is training its own multimodal model, or maybe, for example, you're a team that's looking to implement it into your product. What do you kind of need to know to sort of make it work? Um, so there's a couple different points I'm really that I want to kind of give more of a high level overview about. There's a ton of resources I'm really happy to recommend if you want to contact me on LinkedIn or Twitter that I kind of weave into this talk. But the main things I want to hit are one, answering the question of what is a multimodal model at a very high level. The second point I want to cover was, what are the use cases and applications? Uh, Third, just a quick coverage on what are the current multimodal models out there. The fourth one, which is really important, which is performance and evaluation. What are your options? How do you do it? The fifth is development and training best practices, and not just the challenges behind using it that we'll kind of see, but also what are some best practices for teams that we've observed that are currently implementing multimodal models in either their internal or external facing features. So, but really quickly about me. So I currently lead developer relations at Ladlebox. We're data-centric AI platform for generative AI that a lot of our customers use us for labeling and evaluation, as well as our our human expert labelers. Before I joined Ladlebox, I worked as an MLOps engineer. I did MLOps at Futureform and Mailchimp, as well as have worked as a data scientist and data analyst. But the general theme of my kind of career is just building AI products. What does it take, both from from the from bottoms up to top down approach? So once again, I work at Ladlebox. We call ourselves the data factory for next gen AI. A lot of our customers are in fact using us to train and develop the next foundation or frontier models. So there's a QR code at the end of the presentation. Please do check us out. So let's just do a 101 on like what are multimodal models. And let's just start with kind of, a really basic definition. So, multimodal models are AI systems designed to process and generate multiple types of data simultaneously, such as text, images, and audio. They handle multimodal inputs and outputs by integrating different sensory information into a cohesive understanding, allowing for enhanced comprehension and generation capabilities. Some of the different modalities include text, image, code, video, music, 3D. There's so many different types of data out there, and some of the most popular ones are, text to image, text to code, text to video is really really popular right now. But ultimately, the goal is to any kind of information that humans would normally interact in our data to be able to incorporate it into a single model or system. So why should we care about multimodal? So let's kind of go back to this, definition I presented, the second part. Specifically focusing on the cohesive understanding, the enhanced comprehension, and generation capabilities. So, multimodal models matter because they enable AI systems to process and integrate all this information. Understanding these models is crucial for leveraging their potential across various applications and driving the future of AI towards achieving human level intelligence and beyond. So let's dig in a little bit deeper. Okay, so what do we mean by enhanced understanding interaction? What we mean is like comprehensive perception. Multimodal models can process and integrate all the types of information that, we would normally incorporate to understand and interact with the world in a more holistic manner. So definitely, like, we want to try to mimic human perception as much as possible, where we use sight, sound, all these other senses to kind of navigate our environment. The second part is this improved performance in complex tasks. So, if we can think about it, like, there's a couple different use cases, right? So, for example, healthcare diagnostics. Wouldn't it be great if we could use multimodal models to integrate, different types of like medical imaging, like MRI, CT scans, X-rays, with patient history and verbal symptoms to get more accurate disease diagnoses. We Multimodal models and smart home assistants. So devices like Amazon Alexa and Google Home can use voice commands, physical interaction, as well as visual clues to operate effectively. So these multimodal capabilities, they enhance our ability to use them as consumers of these products. But what gets people really, really excited about multimodal models is the potential for creating intelligent systems that can interact with the world like humans do, right? So this human level AI, their multimodal models are really seen as a step towards achieving this human level AI, and seen as crucial for creating these AI systems. So I talked about two potential use cases and applications. What are some of the other ones? I mean, there's a ton, right? So healthcare, I've already covered. You know, Robotics and autonomous driving, that is a really, really popular one. So you can combine visual data from cameras, spatial data like LiDAR, and auditory signals to navigate and make these real time decisions for enhanced navigation safety. A really popular use case in e commerce or retail is personalized recommendations. So you integrate user behavior, visual preferences, and purchase history to improve personalized recommendations in multimedia services like news, music, and short video platforms. Um, Immersive experiences for gaming entertainment. You create more interactive experiences by combining the visual, auditory, and haptic feedback, right? So, for example, if you're playing Speed Racer or Grand Theft Auto, but on a VR headset. So you can also enhance user interactions. So, for example, aiding visually impaired individuals by integrating audio descriptions, tactile feedback, and visual clues to provide a richer understanding of their surroundings. Context aware customer service systems, you name it. So there's a lot of different use cases, very valuable ones for multimodal models and systems. And, this is just an example. So we talked about, healthcare diagnostics. So this kind of shows you all the different information that could be used for, generating diagnosis in precision oncology, all different types of data, the different processes that you would normally have to go through, right? So this is just kind of, summarizing the information I'd already given, but definitely check out our site for more use cases that we're adding based off what our customers are doing. So current multimodal models available. So there's a bunch, and it's definitely increased over the last 2 years specifically. Some really popular ones include GPT-4V, Quen, Gemini, Flamingo, you name it. And, something that you'll sort of observe is that, as you see this growth of LMs, you'll also see, sort of related growth in MLLMs, which are a particular category of multimodal models. And the reason why is because LLMs do form a crucial component in MLLMs. So as those get better, so do MLLMs and multimodal models. And this is just to illustrate that, we first saw this, like, initial wave of innovation in LLMs, which is still continuing. But that really kind of paved the way for MLLMs. And, what you'll see is that there were different types of techniques that were used to improve LLMs that are also used to improve MLMs as well, including using synthetic data, RLHF, better like task data, things like that. Now, in terms of like how many models are out there, there's a lot. So right now on Hugging Face, there are more than 20,000 text image generative models, which is just a very specific subset of multimodal models. So if you were to include all of them and, do some like deduplication and all that, you'd probably get to like a pretty large number that we just could not fit on a single slide. Now, in terms of, why MLMs are so important, it's really an extension of this question of like, we've seen the success in the LM world. Can we extend the success of LMs to MLMs? And get that same kind of get an even bigger wow moment. Now, this is an evolution, right? So multimodal models, they're not going to just get better immediately, and they are still going to take a little bit of time, but a lot of the impressive reasoning and understanding ability that we've kind of seen with, like, for example, chat-based visual language models. Like in this case for OpenAI, we've seen like essentially every single iteration has just gotten better. So we'll kind of see that too with multimodal models. Okay, so how do these things like actually work? So I'm going to give you just a very high level explanation. I'd encourage you to read papers like, survey of multimodal model architectures and things like that. But this is just to give you kind of a working, although very imprecise and probably somewhat inaccurate way to think about it. So in order to really kind of understand multimodal models and like the steps to get to human level AI, there's a bunch of these kind of different sort of dimensions you have to look at. We're only going to touch on like a few of these today, and even that in a very kind of shallow way. Multimodal models are kind of interesting in that they combine a lot of the capabilities and features that you see in like large vision models, in visual language models, generative models, but they're capable of so much more. Okay, so 90% of MLMs will fall into this architecture of an encoder, then encoder, LM, decoder architecture. What's happening in this kind of architecture? So in a multimodal model with an encoder, LM, decoder architecture, so you have encoders which take raw inputs like text, images, or audios and convert them into embeddings. These embeddings are then processed and tokenized to be understood by the core model, usually an LLM. And then you have decoders that then take the process embeddings and generate the final outputs like a text description of an image or an audio file from text. So these are the key components. For multimodal encoding, you can use like visual encoders like ClipVit, non-visual encoders like Whisper for audio, or unified multimodal encoders like ImageBind and LanguageBind. For the tokenization, for multimodal signal tokenization specifically, you can employ methods like Q-former, linear projection, and resampler to convert those multimodal signals into a form understandable by LMs. And then for the multimodal generation, you can utilize diffusion balls and codebooks for generating visual, video, and audio data. There's a different type of multimodal architecture where it's like LM as a controller. This starts looking very similar to multimodal like agents or agentic workflows. But once again, this is a decent, a decent mental model to start with if you are, just approaching multimodal models for the first time. So let's talk about like the development and training best practices around how do you even train or fine tune a multimodal model. We've talked about what it is, but how do you get there? So there's kind of two major components. Uh, the first one is pre-training. So the purpose of pre-training is, this is the initial stage where the model learns to understand and process different modalities like text, images, and audio. Um, the second stage is the instruction tuning stage, and we kind of think of it even further as like kind of two parts. There's a short answer, like visual question answering, and then there is the natural conversation VQA. So for the short answer VQA component, the purpose there is to inject specific domain knowledge efficiently. And then the purpose for the natural conversation VQA is to practice and refine the model skills in a real world application. So the way we can kind of think of each of these sort of stages is for pre-training, you can think of it as creating a dictionary for the model where it learns the vocabularies from each modality. So it learns what certain visual patterns represent images or how certain sounds correlate with words and audio data. That's how you can think of it. And in terms of the method, you expose the model to, sorry about that, a large and diverse data set to build a foundational understanding of each modality. For instruction tuning, for the short answer VQA, the model it's given small focus tasks like puzzles that help it learn how to apply its pre-trained knowledge to specific questions and answers related to images. So it's like giving the model short quizzes to ensure it understands specific aspects of the data it has learned during pre-training. And finally, for this like natural question VQA, right? So this is kind of like practicing language skills by having real conversations rather than just answering short questions on like Duolingo, right? So rather than just kind of answering a bunch of questions on Duolingo, you actually like have a conversation with like a native Spanish speaker if you're learning Spanish. So and here like you want the model to engage in a more complex and natural conversation, where it's understanding and generating contextually appropriate responses. I think everyone's had this experience where you put a prompt into like Stable Diffusion and you're like, I want to see salmon jumping over water, and then it shows you a piece of sashimi sushi jumping over water. And I mean, in terms of kind of what's going on in each stage, so for pre-training, there's kind of three components that are important to the process. The first one is data. So you need to expose them all to large data sets that include diverse types of data. You need to align the model so that it learns to map different modalities into a unified representation space. So that, for example, it learns that the word cat corresponds to images of cats and sounds relate to cats, right? And there's a knowledge piece. You're helping the model build a foundation understanding of the world, which it can later use to reason about multimodal data. In the instruction tuning stage, once again, you're teaching them all to understand and follow instructions from users to perform specific tasks. There's three kind of core components or three important concepts that occur as part of the process. The first one is task-specific data. So the model's fine-tuned on data sets that are more specific to the tasks it performs, and this includes answering visual questions, generating descriptions from images, or converting text to audio. There's instruction understanding, so the model learns how to interpret and act on instructions. For example, it might be taught how to answer questions about an image accurately. And then there's the application. So by the end of the instruction tuning stage, the model should be able to take a user's instruction and perform the demanded task effectively, leveraging its pre-trained knowledge and fine-tuned skills. So to get a sense of, what kind of data you actually kind of need as part of the training and development of a multimodal foundation model, so you definitely need your pre-training data, and this is usually paired. So you have, like, for example, an image with some bounding boxes, and you have a text description of like what the object is, and you can have coarse-grained image text versus like fine-grained image text. So fine-grained is like it has longer, more like pretty descriptions. Maybe has colors and shapes and things like that, right? And also it could also include like higher quality image data as well. And in terms of instruction data, so this is what like instruction data looks like. So like we mentioned, right, you would ideally have some kind of like bounding boxes, and they have an associated description. Um, and then you have like the task specification, all that good stuff. So something to kind of point out here. So the other like data set that you need to train a multimodal model, especially one that's used in a chat capacity, is the instruction tuning data set. And what you'll see actually is that in terms of like data set sizes, usually the instruction tune data set is smaller than like, for example, the pre-training data set that's paired. But this is also where instruction tuning is usually where the quality of the data matters even more. So we kind of just covered, what like a very high level architecture of like a multimodal model, but there are plenty of different architectures that exist. Um, One of them, the most common one, and once again, this is just kind of reinforcing the how much data do you need to do a really good multimodal model. So your pre-training is almost always going to be, you need a higher volume, especially if you're covering like more modalities. Your instruction tuning data sets are going to be smaller, but it still needs to be like very, very high quality. So uh, I don't know how many folks here are, have been struggling with measuring and evaluating LMs, but I can definitely say that multimodal models are a lot more complicated to evaluate. One reason why is just because different multimodal models cover different modalities in terms of what you can input versus like also what it outputs. So you have to be careful that you're doing like an apples to apples comparison like between two different models. Um, because for example, some multimodals can do better on some tasks than others, and also some might have specific requirements around how you upload certain types of data, like image sizes, image quality, things like that. So how are we supposed to measure and evaluate them? And there's a couple different ways. One possible way is you use all these existing metrics for the specific modalities. Uh, an- Another way is, and if you go down that route, then the question is, do you then do like, for example, for if you have n different modalities represented, do you then do like n times evaluation metrics? Would it be easier to use like a standard data set to run a benchmark? Maybe create new metrics. Do an arena style type battle. So there's not, I hate to say it, but there's not like one metric or set of metrics to rule them all. It really depends. But let's just kind of cover like what metrics do exist for you to use. And I've grouped them into a couple different categories. First one is your like basic metrics. You have your retrieval and generative metrics. You have your task specific metrics. Hallucination detection metrics. That's really important because once again, LMs are a core component of multimodal models, and we do know LMs hallucinate. There's metrics around user preferences, and there's also more kind of comprehensive benchmarks. So let's just kind of, I'll just go through a couple examples of each one. So basic metrics, like things like accuracy, precision recall, efficiency, zero shot learning. So you want to understand, for example, how often the model's predictions are correct. You want to understand just how expensive it is, maybe, and also, can it handle tasks it hasn't been explicitly trained on? A second set is retrieval and generative metrics, or what we think of as like kind of the advanced performance ones. So retrieval accuracy, measuring how well the model can retrieve the correct text given an image and vice versa. For generative performance, like measuring like how good is the quality and relevance of the generated outputs. You have more sort of holistic assessment tools. Other kind of Retrieval related metrics include precision, recall, F1 score, blue and rouge scores. These are metrics for evaluating the quality of generated text, focusing on n-gram overlap. Another set of metrics is around user preferences. So you have, for example, an ELO rating system used to rank generative models based on user preferences. You have the Bradley-Terry models. These are mentioned in the paper Gen AI Arena. Second to last set of metrics is hallucination detection. So chair, Pope, some of the LM-based ones. We also have all the task-specific ones. For VQA, image captioning, speech recognition, video understanding, speech text recognition. So for VQA, you can have accuracy, you can have MRR, mean reciprocal rank, you can have visual grounding. Example metrics for image captioning include blue score, CIDR score. For speech recognition, we have word error rate. For scene text recognition, so basically there's a bunch of these. You can go look them up. But for every kind of task that has been done in computer vision NLP, it has some related metrics that people can use, and you might want to consider using those, right? And finally, we have more kind of comprehensive evaluation. So there's your arena style, your benchmarks, your models as judges. You have your human evaluation with expert labelers and expert evaluators. So, measuring multimodal models, it's like LLMs, but just way more complicated. So you do need to be very judicious and understand what exactly are you trying to measure. So as we kind of hinted, there are some challenges of developing and using multimodal models. So let's just kind of go through what they are. So roughly, there are 5 different categories. Data challenges, including instruction tuning, challenges around technical and optimization, challenges around resource and computational needs, quality and evaluation. We've already sort of kind of touched on that, and applications and use cases. So, for example, in terms of what do we mean by technical and optimization challenges? How do you balance the compute cost with the model performance? How do you ensure model stability, right? How do you even things, for example, handling numerical issues, right? If you're, for example, incorporating if you're doing stuff with the embeddings, if you're doing things like that, right? We have computational resource challenges. So for example, multimodal models a lot of LLMs, they can require pretty extensive computational resources, especially if you're training them. So you might need a lot of GPUs. Typically you're dealing with large diverse data sets, so you need some amount of extensive data storage. There's also kind of the scaling challenges of you have to manage so many different types of data sets, and you have to manage the labels, and you have to handle the failures that can happen when you're running a multimodal model. You have to make sure they're highly available, because a lot of times, once again, they're hidden behind a chatbot. It's kind of expected that they would be ready and available and easy to use. So those are things that have to be considered. We already talked about quality and evaluation challenges. How do you know if it's going well? Now, one set of challenges that actually teams have the ability to influence and improve is data challenges, including instruction tuning data sets, right? So kind of main 3 things are one, data preprocessing, ensuring that you have consistent formatting quality across different data types, making sure that you have data preparation pipelines for filtering and deduplication and enrichment, as well as developing instruction tuning frameworks and generating these high quality instruction data sets. Why are these data challenges important, and why do they exist? Well, there was this idea that with foundation models and frontier models, companies didn't necessarily need to be so data centric, because essentially you're sort of offloading all this pre-training onto, for example, Anthropic or Mixtral or GCP or you name it, right? You don't have to deal with pre-training, so why do you need to deal with data? And that's actually not quite the case. There's a lot of data-centric workflows and processes that need to be considered if you're training or using MLMs. Uh, for example, your data collection, the data sources that you're pulling in. If you're training it, this is really, really important. And even if you're like fine tuning or just running prompts through like an MLM, you do want to consider, for example, what, like, where's your data coming from? What's the composition of it? How are you cleaning it? How are you leveraging existing data sets that are out there? What's the composition quality? Like, how do you incorporate that to do that, like, supervised fine tuning, to make it kind of more um, more responsive to like what you want it to do? And how do you evaluate the data as well? So this is a pretty significant set of challenges that sometimes when teams are approaching like training a multimodal model, they don't really they think it's like training an LM, and some things are similar, but some things are not. So, what are some of these like best practices for developing and deploying um, multimodal models, and especially MLMs? So here's just kind of a general list or ordering, I think, based on like feasibility and value, i.e., there are things that are more valuable to do and are probably more feasible to do, especially if you're like a small company or startup, and versus like if you're a big company like Facebook or uh, GCP, you name it, that you would kind of think about it. So some factors for like being really successful in either training and or using multimodal models come down to data, everything data. So generation quality, the processes supporting it, what you're doing for inferencing and serving, how you're approaching fine tuning. If you do decide to make algorithmic optimizations and create kind of your own architectures or extend on existing ones, infrastructure needs. So let's just talk about data, right? So there are definitely things that teams can do to, make efforts around incorporating multimodal models work for them. So first one is investing in efficient data handling, as well as like using pre-trained models. It basically what it comes down to is, if you don't need to like pre-train or train a multimodal model from scratch, if you can just like use an existing one for zero shot, definitely do it. And you also want to implement efficient data handling processes, scalable data pipelines, and like having the compute resources to like handle them. Pretty important. Good data preparation and management. So having good like data management practices, especially ones that can handle the diversity of data that you're dealing with. Fine tuning. So if you are fine tuning, there's some techniques you can look at. So techniques for like adapting pre-trained models, which include, representation transfer, model fine tuning, adapter tuning, prompt tuning. You can do stuff in the visual supervision and reinforcement learning area. So like for mitigating hallucinations and enhancing alignment, you can use contractive loss, RLHF, things like that. And then you can also try optimizing model components. So like optimizing your visual encoders and vision language connectors, like using a balanced mix of data types, incorporating synthetic data for few shot learning. At the end of the day, like regardless of whether you're doing like multimodal models or just your like uni models or traditional deep learning, the hardest part of doing like any kind of AI well, whether it's generative versus other kinds, is like creating a good AI data flywheel. So being able to continuously update your models with new data, either instruction data sets or pre-training data sets or additional like fine-tuning data, and having it uh, incorporate efficient training and fine tuning techniques and being able to maintain it so you have like a really good multimodal, like that's pretty hard. Um, Getting it set up the first time is always challenging, but to kind of continuously make sure, yeah, you're deriving value from your multimodal model in production uh, can be kind of tricky. And that's, I think, actually the AI data flywheel is literally one of the hardest parts of like doing any kind of generative AI product. So needless to say, like kind of all generative AI efforts are data centric. So we, you know, here I'm just like, demonstrating kind of the process for model distillation, how that kind of fits into building intelligent apps. And I mean, some of the details are different, but for example, like RLHF, super important. Being able to fine tune models either to get like a different sort of stylistic behavior, things like that. So all generative AI efforts are data centric. How multimodal models compare to unimodal models? I mean, basically, like, do you still want to use them, knowing that there are so many layers of potential complexity? Um, and the short answer is yeah, probably. And there's a couple of reasons why. Some of them we've covered. So, for example, multimodal models excel in enhanced understanding, right? So because they can integrate and process all this information from different modalities, you can get a more comprehensive understanding of complex inputs, more so than like unimodal models, which are limited to processing information from a single modality. So that can kind of really restrict their understanding and application scope. Performance and capabilities. So in like really complex tasks, multimodal models can show superior performance, like especially in things that normally require like multiple data types and multiple steps, more so than a unimodal model. You have more information to work with. Sorry about that. Generative abilities. So multimodal models can generate tons of different diverse outputs, especially if that's how they're trained and structured. Which can be used in applications like image captioning, video summarization, and more like cross-modal generation. With unimodal models, they're typically limited to just generating outputs within their modality. So if you need an image and it doesn't generate an image, then you can't use it. Same with audio. Zero shot and few shot learning. Multimodals also can do better in this area. Just because once again they can leverage different data types. So they can adapt to new tasks without necessarily extensive retraining, especially if they're using like a really decent LLM. And yeah, applications and use cases. Like there's a ton of applications for multimodal models. And they can essentially replace what would normally have taken like a chain of like 20 different models, right, to do. So you have you have like two or three models for NLP tasks. You have two or three models for computer vision tasks. And so multimodals kind of, in that regard, they can make things a lot simpler if you're okay with the performance of like zero shot and few shot. Yeah, so this was a little bit of a whirlwind. It was just meant to be a high level sort of introduction to how to make multimodal models work, talk a little bit about the data requirements, especially on making multimodal models work. Um, I would highly recommend. So if you weren't able to attend CVPR this year, CVPR had a number of wonderful tutorials and papers being presented. They especially had one on a multimodal tutorial that I would highly recommend people to check out. And CVPR does have a digital pass, so you can go, you can look at the slides, you can also watch the videos to get more details on certain areas where I didn't dive in as much. But what we covered today was one, just understanding at a high level what multimodal models are. We talked about some use cases and applications. We talked about the challenges around performance and evaluation, all the different sort of ways you could approach measuring how a multimodal model works. We discussed best practices around development and training. We talked about how even though there's a lot of challenges in terms of complexity of using them, especially if you're like training or developing the next multimodal model, and we kind of talked about how like you should at least try to use an off the shelf one first because there's so many out there before you do kind of, dive into training the next foundation model. But, there are best practices that are being developed now, and we covered some of them in the last part of this. So if you have questions, if you want to connect with me, please feel free to do so. You can kind of scan the QR code, and you can also just find me on like LinkedIn and Twitter if you search my name. Once again, in terms of Layout Block, so we're a data-centric generative AI platform. We're focused on helping companies do stuff with their unstructured data, not just creating data sets for pre-training, but also for evaluating multimodal use cases, including, for example, the new multimodal chatter that we released. So check us out. Feel free to scan the QR code there, and also once again just to Google search. And yeah, thanks very much for listening to me talk about multimodal models, and really excited to hear what you guys think. Take care. Oh, sorry. I mean, ready for questions.